before the first star burned, before the first atom formed, before even space had somewhere to exist. What if reality was not made of things, but of relationships? Modern physics rests upon two extraordinary pillars. Quantum mechanics explains the microscopic world with breathtaking precision. General relativity explains gravity, stars, galaxies, and the structure of space-time itself. But beneath their elegance lies a profound conflict. Quantum theory assumes space already exists. General relativity says space itself is dynamic. One treats space-time as a stage. The other says the stage can bend, ripple, and collapse. So physicists began asking a dangerous question. What if space-time is not fundamental at all? Imagine removing the universe itself. No coordinates, no distances, no geometry, no cosmic background. Only abstract quantum systems connected through relationships. In this framework, the deepest layer of reality is not made of particles moving through space. It is made of quantum nodes carrying internal information, gauge charges, spin states, quantum correlations. The universe becomes a network without a map, a cosmos built entirely from relationships. But if space does not already exist, how can anything be near or far? The answer may lie in quantum entanglement. Entangled systems share information in a way ordinary objects never can. Their states become inseparably linked. And this framework proposes something extraordinary. Distance itself emerges from information. The more information two systems share, the closer they become in emergent space. The less information they share, the farther apart they appear. Space may not be a container holding matter. Space may actually be the shape of entanglement itself. But space is only half the mystery. What about time? At the deepest level, physics allows for a startling possibility. The universe as a whole may be timeless. A frozen quantum state, no flowing seconds, no universal clock, only existence. So why do we experience motion? Why does reality feel alive? This framework suggests that time emerges relationally. One part of the universe acts as a clock. Another part becomes the observed system. And from their quantum relationship, the sensation of temporal flow appears. Time is not an external river carrying reality forward. Time is information comparing itself to itself. Then comes the most astonishing possibility of all. Gravity itself may emerge from quantum information. Changes in entanglement create changes in geometry. Entropy shapes curvature. And remarkably, the equations describing these informational relationships reproduce Einstein's equations of gravity. Gravity may not be fundamental. It may be an emergent consequence of how quantum information organizes itself at large scales. Space-time bends because information changes. Geometry responds to entropy. The universe becomes less like a machine and more like a self-organizing network of relationships. This framework points toward an even stranger horizon, a universe where time itself emerges from the thermal structure of quantum states. No preferred clocks, no universal present moment, only relational flow. If true, space, time, and gravity may all be emergent phenomena, like temperature emerging from molecular motion, or consciousness emerging from neurons. For centuries, humanity searched for the smallest building blocks of reality: particles, fields, strings. But perhaps reality is not built from objects at all. Perhaps it is built from relationships. A universe where distance emerges from entanglement, where time emerges from observation, where gravity emerges from entropy. A universe woven not from matter alone, but from information itself. And if space-time can emerge, then perhaps what we call reality is only the visible surface of something far deeper. The universe may not exist within spacetime. Spacetime may exist within the universe's web of quantum relationships, and somewhere beneath the fabric of existence. The cosmic conversation continues.